Hi, this video is going to help with section 12.8 in course 1, and it's over congruent transformations of a triangle. So basically we've gone through all these rules of congruence for triangles. Well, this section we're going to use those transformations to help us with how one shape is going to move and directly be on the other shape. So let's review these transformations. A big T we let represent a translation. That's where you're going up, down, right, left. So you're moving it around, but it's rigid motion, so that means that the shape itself stays the same. It moves itself. Reflection is like a mirror image, right? So we thought of it as a flipped over some kind of line. So usually we flipped it over the x-axis or the y-axis or a specific line, but it changes because it's going to be flipped over image of itself. So I guess I don't have two of these shapes, do I? I was trying to think of shapes that are a little easier to see. Okay, so this would be an example of a reflection with the line being right down here where it's reflected across. You can kind of see the mirror image. A rotation is where you're going to turn a shape around a certain point. So maybe you're here, maybe your point's about here, and you're going to have the shape still the exact same way. It hasn't been reflected at all, but maybe it's rotated over here or over here somehow, depending on the percent in which you rotate it. Okay, so it's going to be rotated somewhere around that point from this starting point to over here somewhere. So that's a rotation. We also have a glide reflection. And a glide reflection, they got introduced on one of the questions, just one, and it definitely have to be reflected, but if something doesn't reflect right on itself, so if these two are like this, and I move this one over a little, you could tell it's the reflection, but it's not exact. It has a translation in there too, and they call that a glide reflection. And that's only on pictures, and I'll give you an example in a second. So let's see what we're looking at for this. Now, kind of ignore my red dots here for a second, my red part. But if I want to go from ABC to JVK, what is a way that I can use these transformations and get here? Well, one way, and I showed it in red, is to rotate or or reflect over. I was thinking rotation, but rotation would turn, and I want it to actually reflect where I did it in red, and then I want to move it down. Okay, I could have moved it down, then reflected it, so you could have thought of it a couple different ways, but the way that I thought of it was, well, I would reflect it over here. So that is denoted by a big R with us saying over the y-axis, right? Remember, this is your y and this is your x. And then I'm going to move it down in the y, so x's will stay the same, but I'm going to move it down on the y 5. So I counted those off, and it was 5 on each one. And then they would show congruence. Okay? And there might be more than one way, but that's what you're going to be doing. Well, how can I get from one to the other using my rotations? What if I say that you want to verify side angle postulate for a triangle congruence by using transformations? So we know that angle, side angle, these are congruent, but we want to verify by picking up one and lying it on top of the other by using transformations. And you're going to prove this, and you kind of, like it normally does it on Math Excel, it walks you through it. So do try a couple of the problems in the book where you don't have Math Excel walking you through it. But what would be one way that we can get from one to the other? So one way is, we know E and H are congruent by the little symbol, right? If I translate by moving it right here to E, so that moves this shape here to E. I think I have one that's almost exact same. Yeah, check that out. So this looks almost the same, so I'm going to move it so H is now on E, but Are they on top of each other? No. Then I need to rotate it around E until it is this way. Okay, how would I state that? Well, I would say since E is congruent to H, translate so that the point E and H coincide. So they're on top of each other. Next, rotate triangle HLA, that's this one, so that HL overlaps EK. So the congruent side. So I'm like, okay, move it up, and I'm going to make sure the congruent side here and or HL, that's this one, and EK line up. Okay? So that's kind of the idea. So you have to look at it and you have to visualize how you get from one to the other, and that's kind of the harder part. And each problem is a little bit different. All right, so the last question I printed off straight from the example in Math Excel because I wanted a picture similar. This is called a tessellation. I actually have like a bunch of them in my office on the wall. So a tessellation, I don't know if this textbook, I haven't planned the whole textbook out yet, makes you draw one. They're kind of fun. It looks way harder than it is. So what we want to look at for this one is how do I get from A to B? Well, it could just be a reflection, a rotation, or a translation. But if you notice A and B, our tails go the wrong way or a different way. Okay, so it has to be a reflection. But the reflection isn't exact. Like I can't find a line where it would line up on itself. So it would have to be a glide reflection. So that's why I wanted to show you. So going from A to B is a glide reflection. And let me look at another one. Maybe, where's another piece here? Anyway, well, I was trying to see when I should have found a pair. I can't really see any pairs that are an exact. I was trying to find one that's an exact just reflection, but I don't think there is any in this one. They're all glide to get from one shape to the other. All right, so that's kind of the idea of 12-8 is you're just looking over those main transformations here, and you are deciding which ones go to line up our triangles.